Good morning everyone, this is Vrushali. In my last lectures, we discussed about LM35 temperature sensor interfacing with PIC microcontroller, and also we discussed about some previous units points with practical demonstrations. I have mentioned processor architecture playlist link in below description box. Now in this session we will learn the next point, that is interfacing of EEPROM using SPI with PIC microcontroller. So let's see. We will discuss following points in the session, that is SPI serial peripheral interface, EEPROM memory, then interfacing of SPI, interfacing SPI with EEPROM, then circuit diagram of interfacing, then circuit diagram operations, and last one is example. So let's see one by one. Now the first point is SPI. What is SPI? SPI is serial peripheral interface. This is one kind of synchronous communication protocol. We already discussed in detail SPI in our last session. We already discussed what is SPI, working of SPI, their functions, their features, their advantages, disadvantages, each and everything in our last session. I have mentioned the link of that videos in below description box. So here in this session I am giving you just overview regarding SPI. So SPI stands for Serial Peripheral Interface, and it is Synchronous Serial Data Protocol. Means they provide a communication, or they provide sending data, request and response data by using particular clock signals. That's why it is a synchronous serial data communication. So here this SPI protocol generally used for short distance purpose. For example, there is one circuit board and there are lots of components are placed on the same circuit board. So at that time the communication between these peripheral devices or this particular short distance purpose, we use this serial peripheral interface protocol. This protocol also used for communication between two microcontrollers or one master and multiple slaves. For example, master means your microcontroller and slaves means different devices like analog to digital converter like LED, LCD, sensor. So these all are the slave devices. So it performs the communication between one master and multiple slave. So this is an overview of SPI protocol. Next. Now the next point is EEPROM memory. So basically the long form of EEPROM is electrically erasable programmable read only memory. So basically it is a type of read only memory, that is ROM. So generally EEPROM memory is a non-volatile memory. It generally used in different computers and different electronics devices. So what exactly purpose of this memory is, suppose your power is off or your computer is shut down. Still your information or your program is by default saved in the memory. So that memory is called as read only memory. Means small amount of data that must be saved when power is removed. So this is a main feature of this particular memory. This memory generally used in different calibration tables, device configuration, smart cards, then remote keyless systems, because each and every system having a particular user ID or particular password, or this information is permanently stored, or this is a permanent information. So this information is called as EEPROM memory. Next. Now the next point is interfacing of SPI. So we already discussed this interfacing of SPI in our last session in SPI video. I have mentioned link of that video in below description box. Now see here, here is a just overview. See here in this diagram, this is the interfacing of SPI protocol. This is your master, this is your slave. There are total 4 pins. First one is SCK, that is serial clock. For performing this communication, means for sending data or receiving data. For this communication purpose, they use a particular clock signals. And this clock signals always generated by the master to slave. Next one is MOSI, that is master out slave in. It means that sending data, master send data to the peripheral devices. Okay, here master send data to the slave devices. So this is called as MOSI line. And the next pin is MISO, that is master in slave output. Here the slave devices send data to the master. This is request and this is response in this way. And last one is a chip select, that is CS pin, because there are multiple slaves devices are present. So here master was decided that which slave they want to respond or which slave they need to give the information or send the data. So CS pin generally used for to select a particular slave devices. So this CS pin always generated by the master to slave. So basically in the interfacing of SPI there are total 4 pins are used. One, master to slave sending data. Second, slave to master receiving data. Then chip select which slave devices to send the information, and SCK, that is clock signals. So this is interfacing of SPI. Next. Now the next point is interfacing of SPI with EEPROM memory. Now here consider that your master means your microcontroller, right? Or here slave means your EEPROM memory, because this EEPROM memory is also one chip like microcontroller, and this chip is located on your circuit board or your motherboard, right? So here master means microcontroller and slave means your EEPROM memory. So here this communication can be performed by using SPI controller. See here, this is a chip of EEPROM memory. There are total 8 pins are present here. So first pin is S bar. So this S bar pin connected to this CS pin. Okay, that is chip select pin. Next Q. Q means serial data output. So this Q pin is connected to this MISO pin, that is master in slave output for interfacing purpose. Okay. W bar is a write protect. This is auxiliary pin because we need to perform different read and write operation on this memory, that is W bar operation. That is VSS, that is connected to the ground. VCC means positive power supply, that is plus 5 volt power supply. Next hold means they required minimum plus 3.3 volt power supply. This is total power supply, this is minimum power supply required for performing read write operation. Then C means serial clock. So this 6 pin is attached or interface with this serial clock pin, SCK signal. And last one is D, that is serial data output. So this pin is connected to the MOSI, that is master output slave input. So in this way these pins are connected to this particular SPI protocol, and in this way this EEPROM chip is work as a slave, and master means your microcontroller. So here this information can be transferred by using SPI protocol. Next. Now next year, see here in this diagram, this is your PIC 16 microcontroller, okay? And this is your EEPROM memory, SPI EEPROM memory. This is your master, this is your slave. So as per your exam point of view, this diagram is necessary for this question, okay? Now just focus here in this PIC microcontroller diagram. We already discussed pin description in our last session, okay? So first you need to understand what are the different pins are present in this PIC microcontroller. So here we are interested only this pin. See here. First VDD, that is positive power supply. Each and every electronic circuit start from the positive power supply and end with the ground, that is switch off. Now VSS is connected to the ground here. Okay. These are the two pin. Third pin is MCLR, that is master clear reset. If you want to reset your system at that time, this pin will work. Next, oscillators. Oscillators generally used to provide the frequency for performing different read-write operations. And now just focus here. This is a SCL pin and SDO pin in your PIC microcontroller. We already discussed this pin, okay? So SDO means serial data out. Suppose microcontroller want to write the data in your memory, okay? They perform two operations, read or write. Read means they just read the data from your memory, and write means they add data in your memory, okay? Means they stored some additional data in your memory. So here SDO, this pin perform write operation. See here, this SDO pin, that is RC5. This pin is connected to the DO data, that is a data pin. Okay. By this pin they write the data into your memory in this EEPROM memory. And for this purpose they use particular clock signals, that is SCK. And this pin is connected to this clock signals to the EEPROM memory. Now next, this is your write operation, and next one is your read operation. So for read operation purpose they use SDA pin, that is serial data pin, okay, that is RC4. So these all pins are present on port C of your PIC microcontroller. So this SDA pin, see here, this pin is connected to the D1. This is a read operation, okay, and they use particular timer or particular clock signals for performing the read operation. So this pin is also connected to the clock signals, right? So in this way, microcontroller can perform using SPI protocol, that is master and slave. So they perform write and read operation, and basically remaining all the pin, that is your ground pin is connected to the ground here. Hold means they required plus 3.3 volt positive power supply. Hold is connected to the VDD, right? Now here remaining pins are again connected to the VDD. They required particular power supply in ohm format, right? So this is a SPI interfacing with EEPROM with PIC microcontroller. So this is a complete explanation about this. Now this is just again same explanation of this particular circuit diagram. See, we need to perform read, write and erase operation in memory by using SPI, by using PIC microcontroller. So for performing write operation they use SDO pin. Okay, they write some particular data into your memory. And the basic operation is read operation. They read some data in your memory by using microcontroller pins, and they use particular clock signals for performing these operations. So basically we used port C of PIC microcontroller for performing these operations. Now see here, this is just one example regarding this SPI with PIC microcontroller EEPROM interfacing. See here, this is your PIC microcontroller. This is your SPI protocol, okay, and this is your EEPROM memory, and this is your LCD. Suppose this microcontroller want to display some data on this LCD, so microcontroller send this data to EEPROM memory, okay, means whatever the data are stored into this memory, they display on this LCD by using SPI protocol, right? So here one master, that is microcontroller, and multiple slave devices are there, like LCD is one slave device, EEPROM is another slave device, and SPI is another slave device here. One master and multiple slaves. So they performing communication between this SPI by using this SPI protocol. So in this way this interfacing will work. And we already discussed this LCD interfacing in our last session. I have mentioned the link of that videos in below description box. So in this way this interfacing was done. So thank you and keep learning.